This is Michael Prenez-Isbell. I just made a video about strong reference cycles in which I discussed strong references, weak references, and unowned references. And to go over it again briefly, we have a situation where we have two instances owned by local variables, and they each have properties pointing at each other with strong references. In that situation, when both local variables have been nilled out, neither of those instances will be deallocated because they'll be kept alive by their pointers pointing at each other. So the solution to that is to have what I call the second instance, even though they're both equal, being a weak pointer back to the first instance. What that means is that when the first instance's local variable containing it is nilled out, that instance will in fact be deallocated because there's only a weak pointer pointing at it. Also, when you nil out the variable containing the second instance, that instance will also be deallocated since the first instance is already gone and there is nothing pointing at it. You use a weak instance in a case where the first instance might in fact be nil, because you might want the weak reference to stick around, the second instance to stick around when its own local variable is holding on to it. The second case is an unknown instance. In that case, and the example used was person and credit card. A person doesn't always have a credit card, but a credit card always has a person. In this case, there's no, in the example they gave in the book, there's no local variable holding on to the second instance under the credit card because you want it to disappear when the person disappears. So what you would have is an unowned reference pointing from the credit card back to the person, from the second instance back to the first. Now what's going to happen there when you delete the credit card, it's going to immediately drop the or deallocate the first instance, deallocate the person, and because then there is no strong reference whatsoever, including even a local variable reference holding on to the person, it's going to deallocate that instance also. And you use it in that case when the second instance can be nil, but the first instance will never be nil. And those were the usual cases. Now there are two other cases that I want to talk about now in detail where strong reference cycles can occur. And the first one is when you have a case where you have two instances and neither one can be nil. And the second case is the case about closures and capture lists, and we'll get into that second. So the example they use in the book was country and city. So a country always has cities, right? Or at least every country I can think of. And a city always belongs in a country, right? Or I think they use the example a country always has a capital city in the way we think of the world of nation states in this day and age. So in that situation, I'm going to just walk through here and then we'll get into talking about it. You're going to have an unowned property, and in this case, like we had person and credit card, in the same positions, first and second, we're going to have country and city. So in the case of city, we're going to have an unowned property pointing back at a country instance. In the case of country, the first instance, we're going to have an implicitly unwrapped option, or have I got that implicitly unwrapped optional? I'm still getting my tongue wrapped around that phrase. It's an optional with an exclamation point which automatically unwraps the value / not set possibilities and gives you the value of the instance of the variable. Anyway, you're going to have an implicitly unwrapped optional pointing back at the city instance. Okay, so what does that get you? It gets you a situation where you can access, what does it say? Each property can be accessed directly once initialization is complete. No reference cycle. So here's what that means. So I'm showing this here. We have country pointing as an implicitly unwrapped optional at city, and we have city pointing as an unowned at country. And walking into the initializer, so here's what's different about this. Country is going to initialize city. And what that means is that it's going to take part in the two-phase initialization process. Let me walk through that. So we have an initializer. It initializes city. So what's going to go on when it initializes city? So it's going to initialize city. It's going to pass in an instance of itself as a parameter into the city initializer, so that once city receives it, city can set the received country instance to the unowned property on city that points back at the country instance. Okay, that makes sense? So what's the problem? The problem is that at a certain point, that's self, right? When country passes itself in as a parameter, that's self, and self isn't initialized during the first phase of the two-phase initialization cycle. During that phase, instead of running the initializer, what happens is that the properties are initialized. They're all set. Because it's an implicitly unwrapped optional, and because no value has been set to it, it cannot be equal to nothing, so it is equal to nil. So once the city property on the implicitly unwrapped optional city property on the country instance is set to nil, and the other properties are set, like name, that means that that's a fully initialized instance of country, even if that property is nil. That means that in the second phase of the two-phase initialization process, now country can be passed into city. So let's think about that. So now phase one, city property on the country instance set to nil. Now we have a fully fledged country instance. Phase two, city initializer run from the country point of view, country passed in to city. Now the city initializer is run, and from the point of view of city, it's receiving the country instance with its nil pointer to city set. City then sets the unowned country property on the city instance to the country instance. That completes. Pop back up the stack to the second phase of the country initializer. Now that city instance is set to the implicitly unwrapped optional, so it is now no longer nil, which means that the country instance being referred to in the city instance is also no longer nil, right? The country, in other words, it's a reference pointing back to the same object, right? So that's the way that works. It's a little confusing, but it's actually a very elegant way to allow you to refer to self inside a closure. It's kind of cool. So just to walk through it, phase one, city property on the country instance is set to nil. So country is fully initialized once the name property is set, right? Because now that nil counts as a fully initialized instance. Now the country can pass its implicit self property to the city initializer, and it does. Now country runs that city initializer, so he pops the city initializer onto the stack. The city sets the passed in country instance to the country property. Now the country sets the city property to a new city instance, and now the city's country property has a pointer to the city instance in the city. And it's city property too, right? That makes sense, right? Good. And I have a reminder here about two-phase initialization. Phase 1, each stored property is assigned an initial value. You can't access any property before it's initialized with a value or a nil. Phase 2, now you can customize the properties as you wish. Okay, that's how it's designed. Very good. So now you have a city that points at a country and a country that points at a city. And when country is nilled out in its local variable, then city will go away too, because once again it's an unowned property, and the cascading delete that happens in the same situation with the ordinary unowned property when a strong reference is pointing back will also work. So now let's talk about closures and capture lists. Closures, of course, are blocks of functionality that get passed around as defined by curly braces. We're talking about the case where a closure captures a variable in the enclosing scope and establishes a strong pointer to it. Now, what does that mean? So closures are strong references, just as classes are. Closures, excuse me, that's not correct. Let's fix that. Closures are reference types. Right? Just like classes are. Value types are enums, tuples, and structures, right? Ints and things are actually structures under the hood. So that's what Swift consists of. You can create a strong reference cycle with a closure. How does that work? Here's what that means. So you have a closure and you have an instance, and you've got a closure, and you're going to assign that closure to a property on your instance. Now, because it's a reference type, once you assign it to that property, that instance now is a strong reference to that closure. Simple enough, just as if it had a strong reference to a class, right? Now here's the problem. So you go inside the body of the closure, it runs, it points to another property back on the instance, say for instance name. So it says self.name. Bing, once you say self and refer to self from the body of that closure, that establishes internally a strong reference pointing from that closure back to the instance that it's pointing at. And now you have a strong reference cycle. If you nil out the instance that's pointing at the closure, neither one of them will ever go away, and you'll have a memory leak. Okay. This happens with either a property or a method. So if you call a method or refer to a property, that's what will happen. The solution is closure capture lists. Simple in concept. At the beginning of a closure, either before the parameter list or before an in statement, if there is no parameter list, you put brackets and then say weak self or unowned self if self is the instance you're capturing. You might be capturing some other instance. And that depends upon whether you're going to be pointing at an instance that might go away and have a nil pointer, and you want to save the closure for some reason, or if it's an instance that will never be nil, and when it does go away, the closure will go away at the same time. Okay, you can have those that closure capture list with commas and list a number of instances that you want to annotate their capture. If you don't annotate the capture with weak or unknown, it continues to be a strong reference. Right, and I just talk about which one you want, again, whether you want a weak or an unowned for the reasons that I just indicated. Lazy properties are interesting. So let's think about that closure again. Do you always want to use a lazy property for a closure? Not always. So when? Well, if you're not referring to the self instance inside the closure, you can just go ahead and assign it to a standard storage property. If you're assigning a closure to a property and you're referring to, in the body of that closure, you're referring to the instance self, then a lazy property will let you do that. And so how does that work? Well, lazy storage properties don't initialize themselves until the first time they're called. So you can't call a method on an instance until that object is initialized, right? So if you're referring to self inside the body of that closure, you can't refer to self until the self is initialized. So you can't. So if you try to do that from the body of a closure that's been assigned to a non-lazy property, you'll get a crash of some kind, or it won't compile. One of the two. I don't know which. If you assign it to a lazy storage property, what will happen is first the instance will be initialized, and then at some point some method will call self, right? And when that method calls self, it will happily find that the instance is there and self will work fine. But it needs that delayed lazy reaction in order to work correctly. Here's an interview question. If you refer to self many times from inside a closure body, how many times is a strong reference captured? The answer is once, right? Once and once only. And always note, you always have to write self.whatever, self.some property or self.some method within a closure. You can't drop self and just say some method or some property. It won't work. The closure won't know what you're talking about. And I think that's about it. So just to quickly review, the ways you're going to be dealing with things. 1, strong reference cycle. You want to lose memory, so you have two strong references pointing at each other. It's probably not going to happen. Number 2, you have an instance that's going to be nil, so you have a weak pointer pointing at it that lets you get rid of that instance but still keep the second instance around, but there's no problem with the memory leak. Number 3, the first instance is never going to disappear, and furthermore, you want the second instance to disappear when the first is nilled out in the local variable level. That's when you use an unowned pointer. Number 3, neither one of them is ever going to be nil, but you still want them, the second instance to disappear when the first instance goes away. So what you do is create an unwrapped an explicitly unwrapped optional pointing at the second instance. What that does is give you an opportunity in the initializer to pull a trick and initialize the second instance from within the first instance's initializer, right? Even though you're passing in a nil, on the second pass of the in the second phase of the initialization, the initializer is called, and that implicitly unwrapped optional gets set to the initial instance that you called. So it all works out nicely. And finally, capturing strong references in closures. You're very simply, so the problem there is that you're going to be capturing strong references in closures if you don't, once you refer to self or another instance from within the closure, creating a strong reference cycle. You don't want to do that, so what you want to do is mark the instances that you're going to be referring to with capture lists, bracket, weak, self, close bracket, bracket, unowned self, close bracket. Put at the beginning of the closure before the parameter list, before the end statement. And you want to pay particular attention to when you're referring to self inside a body and assigning it to a property. You want to make sure the property is a lazy property so that self is available on the first call to that property after the instance has been initialized, right? And you're able to have a count on having self there to be referred to. Reminder, lazy storage properties are only set initialized the first time they're called, so they're not set on assignment on initialization of the object as non-lazy ordinary storage properties are. And I hope that's helpful.